Okay, I'm on a recruitment trail here because we're going to create the best club at Lake High School. Well, it's not created. We're going to reinvent it. The Spirit Club is coming back with 2 new advisors, Mr. Buckerfield and me. We're running Spirit Club. How did they approve that? You wait till you see. Got it. So we are going to be in charge of ramping up some spirit around here. So listen for the announcement. Okay, I'll expect all of you to join. We'll have some signs. We'll plan the pep rallies. We'll do all the good stuff. Okay, so, and I'm being serious. You're in, Dakota. Okay, you're in. Okay, so you got to show spirit for all your fellow athletes and people who participate in things. So we're going to do that. So I just want to give you a heads up. Everybody's welcome. Everybody's welcome. All right. You're also welcome to ask questions about the homework. Okay, nobody.
Can you go for number 83?
83. Is that the rectangle? Yep. Yeah. All right, let me hit that in a second. I got 87 written out. I just want to make sure you're okay on 87. For this one.
Oh, I got it.
You got it?
Yeah.
Now, the final answer is what? 38. Because you got to take the number of trees and add it to the original, which was 26. So you get 12. But then the way the question is worded, the final answer would be 38. Like how many total trees? So if I remember right, you get 26 trees that produce 500 apples. Is that what we're dealing with? For every tree you plant, you lose 10 apples per tree. So you do 26 plus x times 500 minus 10x. And then when you get that simplified, it's negative 10x squared plus 240x plus 13,000. That gives us 12 for that vertex. And then, so now I don't think they asked for the total amount produced, but if you plug 12 in, that would give you that value. For 94, you find that height. For part B, it says, where does it hit the ground? Is that right? You can graph that. You can graph that. And so for 94, if like you get negative 16x squared plus 64x plus 336, if you hit graph, it looks like that, which really means nothing to you. I mean, you could figure out the answer from here. But this is one of the reasons I always kind of tell you, say, what's the y-intercept? Well, what would be the y-intercept for that graph? 336, right? And what's the highest point it hits? 400. So right now, why don't we see anything on our graph? Because my window only goes up to a max of what? 10. So if you have an idea where it's going, I can change my window, and I would at least go above 400. I'm just going to make it 450. I like to change my scale. You can get away with not, but I like to do that. So now it at least gives you, a decent, better looking picture. Now we want to know right there where it hits the ground. That's where it hits the ground. That's the highest point. If you look at your table, at 0 it'd be 336. 1 it'd be 384 feet. 2 it'd be 400. It's going to keep going up, but then eventually it goes back down. And so if you hit second calculate 0, I can figure that out. Left bound, I just need to be to the left of it. And right bound there. Guess. So 7 seconds for that. All right, we had a question on 83. So we got a rectangle. What's the perimeter of this rectangle? Is it 40? 80. 80. So perimeter equals 80. Here's my length. Here's my width. Anybody get it? Without just looking in the back? Oh, somebody had to get it. Oh, Anna? Well, all right, what'd you do, Anna?
I did, so it's the area equals length times width. So a of x equals x times, and then I have 40 minus x
A of x equals x times 40 minus x. All right, now this is my length and width, or width and length. All right, this is where the 40 minus x comes into play. We know the perimeter is 80. How do you find the perimeter of a rectangle? What do you add up together? You add the two lengths and the two widths. So the perimeter equals 2L plus 2W. All you got to do is isolate one of them. Let me isolate the W. So P minus 2L, perimeter is 80. So let me make that 80. Minus 2L equals 2W. Divide by 2. And you get 40 minus L equals W. That's why we got that 40 minus X there. So if X is my width, I just flip-flop the length and the width. If X is my width, then 40 minus X is my length. And so I get A of X equals 40X minus X squared. A of X equals negative X squared plus 40X. I'm just curious what this looks like. So Y equals negative X squared plus 40X. All right, so it keeps going out that way. So I need to change my X window. I'm going to make it 30 just because I know. Oh, that didn't even get far enough. But at least gets me to the height, right? Highest point for that one. But what are we looking for? We're looking for the maximum point, which is the vertex. So we use H equals negative B over 2A, which is negative 40 over 2 times negative 1, which gives me 20. H is not standing for height. H is standing for the x coordinate of the vertex. And then if you plug 20 in, that'll give us our final area, or highest area, which is 400. Here for that one. So that's kind of how you set up that one. So some of these you got to be, you got to be able to set up that equation first. All right, other questions on anything else? Okay, I'm just double checking here. So that was 83, 84 was 1800. All right, good. All right, you do need your calculators out. We're going to do a little bit of graphing with those. When you change your window, you guys know how to get it back to the normal window, negative 10 to 10? Andrew says yes. How do you do it, Andrew?
Window. Oh, zoom. Zoom fit.
Zoom fit. Whoa, okay. Go to Z6. Zoom standard. Z standard. Now there might be other ways to get there, but if you hit Z standard right there, 6, it's going to automatically. Let me get rid of that. Changes your window negative 10 to 10. Okay, for your X and your Y. Okay, for that one. All right. Section 3.2. We're going to spend a lot of this chapter dealing with graphs of polynomials. Part of your test will be, now we're going to use your calculator, but part of the test will be without a calculator, graphing calculator. You got to know how to do these things by hand as well. We're going to talk about what's in behavior, and we're going to find the zeros of a function a little bit here today. All right, first things first, calculate f of negative 2 and f of 2. So just plug those in and see what you get. Brandon, let me know what you get.
For negative 2, I got 12. And 10.
All right, keep working. We'll wait. pressure's mounting.
-4.
Oh, and you had to go to Justin for backup. So -4. All right, do we agree with that? 12 and -4? Yeah? All right, now it doesn't look like a lot, but for what we're going to do, that's going to be very beneficial. You see under there what's called the intermediate value theorem. Okay, if f of a and f of b have opposite signs, if one's positive and one's negative. Okay, so if you take a look here, -2, when we plug in -2, we get 12, which is somewhere up here. And when I plug in 2, I get -4. This has to be a continuous function, okay? This has to have a domain. There's nothing that we need to exclude. So I have to be able to connect these 2 points. And if I connect those 2 points, it means I have to cross the x-axis, which is going to become very important for what we're doing. So the intermediate value theorem says if f of a and f of b have opposite signs, one's positive and one's negative, then there has to exist another point, C, between A and B, such that f of C equals 0. Well, at this point, when you look at it, you're like, well, yeah, that's common sense. But that's an important theorem that had to be verified. A couple things you got to watch here. Doesn't matter whether you're A or B, which one's positive, which one's negative. If this is positive and this is negative, it still crosses. If this is negative and this is positive, it still crosses. The one thing you got to watch, it has to cross once, but in reality, it could cross multiple times. Okay, there's nothing to stop you. Depends on how far apart those numbers are. So it could, hit multiple times, but it has to at least hit once. Okay, so that's our intermediate value theorem. Okay, what is a polynomial function? It's something that the definition looks very complicated, but that's how you have to write it in order to classify what a polynomial is. Basically, if you got f of x equals 3x to the 4th minus 2x squared plus 7x minus 8, that's a polynomial function. Couple key things. N are your powers. Okay, we want them in decreasing order down to the constant. A sub n minus 1, that just refers to the coefficients. N has to be a non-negative integer. Has to be positive, and an integer means it's a whole number. Okay, it has to be a whole number. So you can't have it can't be -4. Cannot be like a 1/2. It cannot be a decimal. You have to have nice whole number powers. Those are polynomials. All right, now with polynomials, a couple of properties. The domain is a set of all real numbers. You're not going to come across a 0 in a denominator, and you're not going to come across a radical. So there's no negatives underneath the radical we need to worry about. Set of all real numbers. The graph is continuous. Okay, no holes or gaps. It's not like those piecewise functions where they can jump. Okay. And the third thing, it's a smooth curve. Smooth curve. Okay, you're not going to have any sharp corners. It's not going to be linear at any point. Well, except the first degree will be linear. But anything above that will be some form of a curve. Okay, a couple of key things now we're going to talk about. End behavior and then roots, their multiplicity. Okay, end behavior of graphs. We're going to use what's called a power function to kind of investigate that. So you're down there at the bottom. It is just a single term. So a power function that's going to be a positive whole number. If n is even and a is greater than 0, so say f of x equals 2x squared, g of x equals x to the 4th, h of x equals 5x to the 6th. It doesn't matter. They're all going to have the basic shape. What are they going to look like? Okay, and if you don't know, let's plug in. What does x to the 4th look like? So if I go y equals x to the 4th, Okay, that's what it looks like. What about 7? Let me clear that out. X to the 6th power. They all open up. Okay, they basically look like parabolas. So if n is even, and you have a positive coefficient in front, it's going to look something like that. It might be a little skinnier, might go quicker up, it might be a little wider, but it's got to look like that. All right, end behavior. Basically saying as x gets bigger, what happens to f of x? Okay, as x goes to infinity, as we plug in bigger and bigger and bigger x values, what happens to the y values? They get bigger and bigger and bigger. So f of x goes to infinity. As we plug in negative values, since it's an even power, what happens to f of x? It also goes to infinity. So that's what we talk about with n behavior. Now, what if n is even and a is less than 0? So you got f of x is negative x squared. G of x is negative 2x to the 4th. What happens to our graph? Matthew, you know?
We'll see.
No say? All right, well, do this. Y equals, clear, negative x squared. And I hit graph. Okay? And then what if I do y equals negative 2x to the 4th power? And I hit graph. It's going to be parabolic in shape, but it opens what? Down. The negative makes it opens down. So it's going to open down. Still is going to hit at 0, 0. All right, as x goes to infinity, where's f of x go to? Negative infinity. As x goes to negative infinity, where's f of x go to? Negative infinity. They both go to negative infinity. If you have an even power, 2, 4, 6, they both will open up, both ends will open up, or they'll open down. Okay, they'll both open up, open down. All right, what's that next one say? N is odd and a is greater than 0. All right, what does this look like? First of all, let's make sure we understand what the function would be. A is a positive number, so a could be 1. So I could have x cubed. I could have g of x equals 2x to the 5th. I could have h of x equals 4x to the 7th. I just have to have an odd power. All right, what's that going to look like? Is it going to look the same? Nope, graph x cubed. If you don't remember what it looks like. It was on our little library basic functions. Okay. It starts low, starts with the negatives and goes high. Because think about this, if I plug in negative 2, a negative 2 cubed comes back negative 8. Once I get to the positives, come back as positive. Not the same look as the 2 up above. How do I define the end behavior? As x goes to infinity, f of x goes to, as x gets bigger and bigger and bigger, the y's also get bigger and bigger and bigger. So it goes to infinity. And as x goes to negative infinity, f of x goes to negative infinity. What if n is odd and a is less than 0? F of x equals negative x cubed. G of x equals negative 2x to the 5th. All right, what happens there? So let me just plug in y equals negative 2x to the 5th power. And I got an extra negative there. Delete. Just does what? Just flips. So now, looks like this. End behavior. As x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, as we plug in smaller and smaller x values, it gets bigger and bigger and bigger. All right, once you got that, flip it over. So that's with a power function. Power functions are basic because you only got one term. You're just looking at the one power. What if you got this big long function here? So under number 1, put down 3x cubed minus 2x squared plus x minus 4. I would need to describe the end behavior. As it goes to the right, are the numbers getting bigger or are they getting smaller? The end behavior is determined. The only thing you need to look at is its leading term. The leading term is its highest degree. So if it's not in order, you got to make sure you put it in order. That's the only thing I need to look at. Right there. That tells me the end behavior. Because the highest degree is going to dominate the equation. Okay, the other ones are just going to, they'll affect it, but this one is going to have the biggest effect. So this is 3x cubed, an odd degree, an even power. If you need to look at the front, what does that graph look like? Just the general shape. Okay, it starts low and goes high, right? What's its end behavior? As x goes to infinity, f of x also goes to infinity. And as x goes to negative infinity, it gets smaller. F of x goes to negative infinity. Now, it doesn't mean it'll have that exact shape. That just means to the left, it's going to go down, and to the right, it's going to go up. There might be some twists and turns in there, but just to the left and to the right, it has to have that end behavior. All right, take a look at this one. Copy that one down. If you think you know the end behavior, write it down. Carter, you know the end behavior?
I said it was as x goes to infinity, f of x goes to infinity, as x goes to negative infinity, f of x goes to infinity.
Don't disagree. Because what about that negative in front? So which way does an even power open if it has a negative in front? This is going to be the case there. If that constant is less than 0, it's actually going to open what?
Down.
Down. So it's going to open down here. So that opens down. So it's going to go to negative infinity for both of those. F of x goes to negative infinity. Does not matter about x cubed. It does not matter about x. It does not matter about the 1. It's just as we go all the way to the right, all the way to the left, this is what's going to happen. Now, there could be a lot more going on in between there, but it just has to start and end that way. Okay, so it's probably not going to just be a parabola opening down. There's going to be other action going on. But that's our end behavior. So that's the first thing we got to figure out, what's happening to the left and to the right. Now we got to figure out what's happening in between. One of the main things is where does it hit the x-axis at? Okay. So a couple key things here. So if f of x is a polynomial of degree n, it has at most n real zeros. Zeros are where it hits the x-axis. They're also called roots. The graph also has at most n minus 1 turning points. It could have fewer, but it can have at most. All right, let me just do not draw this on one of those graphs. Those graphs are for something different. But just look. So if f of x equals 3x to the 4th minus 7x cubed plus 2x squared plus 3x minus 8. Jordan, what's my degree?
What? Sorry.
What's the degree of this function?
I have no clue.
The degree is just the highest exponent.
Yeah.
So it would be 4. So my degree is 4. So that is, so it can have how many zeros? Okay, Holly, how many zeros can it have at most? 4. So if you would graph this, so it could potentially have 1, 2, whoops, let me move that a little bit further away. 2, 3, 4. So you can have 4, you can't hit more than that. End behavior, does it have to both open up or both open down? This is a positive number front. Both open up. So it's got to, could it most hit through here? Now the number of turning points, if I got 4 zeros, would be 1, 2, 3. So that's where you get the n minus 1. All right, so try and put this all together. I could have 1, 2, 3, 4 zeros. That gives me 1, 2, 3. Now it could be fewer than that, but that's the most it can have. So we want to see how the equation affects the number of zeros. All right, this, don't put this down either. This is not on your notes. Go ahead and just graph that in your calculator. And I want you to pay attention to the zeros. Okay, where does it hit the x-axis? And then think, what degree is it? Okay, what degree is it? Think about its end behavior. All right, now let's. We got this here. Y equals x to the third plus 5x squared plus 2x minus 8. I got 1, 2, 3 zeros, and I got 2 turning points. That makes sense. All right. Under y2, leave y1 in there. Leave y1 in there. And for y2, graph this one. Okay, graph that one. What do you see? So what?
Same thing.
Same thing. Do you see anything different? Okay. So when you graph it, you're looking at it, and you don't see a separate graph. So you hit graph, and then it just looks like that. If you want to really double check, go to your table. So when I plug in -1, I get the same number in both answers. All right. Where does it hit the zero? Where does it hit the x-axis at? Hits it at -4. Where else? -2 and 1. And it looks like this. Which one is it easier to tell where it hits the x-axis? If I write it like this or if I write it like that? Second one, right? Because all you got to do is say, all right, x equals -4. You solve these individually. X equals 1 and x equals -2. So it's going to be a whole lot easier if I write it like this. Well, unfortunately, it's usually written in the top way. So we're going to have to convert. All right, the main thing we're going to look at now is if we have it written in this form, you can tell where it hits the x-axis. Okay. All right. So for number 1, go ahead and write this one down. We're going to do all these kind of separate here. I have it written. Let's just do this first one. In the form so that you know where it's going to hit the x-axis at. So if I got x plus 3 squared times x minus 2, for x plus 3, where's it going to hit the x-axis at? It's going to hit it at -3. So I'm already going to put a dot at -3. For x minus 2, it's going to hit it at 2. All right, go ahead and graph that. Clear the other 2 out. Clear the other 2 out. Now you have to be able to look at it in this form and tell me what degree it is. Okay. And then I'm going to erase this here in a second, but I want you to think about this. So this is f of x. I could write that as x plus 3 times x plus 3 times x minus 2, because you got x plus 3 squared. If you would multiply that all back out, what would be the highest degree I'd come up with? 3rd. Yep, 3. It would be an x to the cube, x to the 3rd. Not sure what else would happen. I have x cubed. So it has to be 3rd degree. It would be a positive x cubed, so the end behavior would have to look like this. And now we know it's going to hit here. So when you graphed it, okay, y equals, clear that out. And I got parentheses x plus 3 squared times x minus 2. Now when you graph it, I'm really concerned about the shape. Like I know it goes underneath here. So when you put it on your paper, just do this. It hits here. And you don't need to make it go all the way down where, it disappears. Just give me the general shape. So it did hit at -3, right? And it did hit at 2. Okay. What we want to take a look at is what happens as we change the powers on the outside of those factors. So what I want you to do now, go ahead and graph x plus 3 cubed times x minus 2. Do that on the second one. And notice any differences. So it still has to hit at -3. It still has to hit at 2. It will not hit the x-axis anywhere else. So I know it hits at 3, -3, and I know it hits at 2. So I go y equals, I'm going to change that to a 3. Right. All right. Does it look exactly the same? No, doesn't look anything the same. What happens though at the what we call the x-intercepts? There's a little bit of movement there. It doesn't go straight through. So when I'm graphing this over here, I want to graph this as coming down, and then it will change, kind of go through before it turns back up. So there's got to be a definite change of direction. It doesn't go straight through. That's called a bend or a squiggle. That is called a bend. The one up above, if it just hits the point and turns around, that's called a bounce. So we kind of got 3 things. It can either bounce, it can bend, or on both of these, it just goes straight through. There's no change. All right. Type in that one. Think about what it's going to do, and then graph it. Now, you don't get a great sense of what the graph is doing because your scale. Because it looks like it just comes down and boom, goes right back up. But like I said, I just want you to graph the overall shape. But it comes down and it hits, bounces back up at -3, and it hits 2 and bounces back up. So there's going to be the general overall shape. So if I go to y equals, and I make that a 2, and then I make that squared. Let's see if that worked. Looks like that. Now if I change my scale, I can make it look a little bit better. So like if I made my Y max, say, 150, let's see what happens there. 25. Then you get that then you get the smooth graph. Okay, so it just has to do with that scale. But that's what's going on. I just want the general shape. So pretend that looks like that. All right, what makes something bounce? What makes a graph bend, and what makes a graph go straight through? Okay. It all has to do with the exponent on the outside of that x plus 3 or x minus 2. Okay. And that's called the multiplicity. So you're there at the bottom. So it's called the multiplicity. If it has a multiplicity of 1, which means that this is the first degree, the graph goes straight through. There's no bend, there's no bounce. It just continues on its path. With if you got some of the newer calculators, it's a little bit easier to see. Mine's a little bit pixelated. Would that be the right term? Yeah, because it's not as smooth. If it has an even multiplicity, if the power on the outside is a 2, a 4, a 6, okay, then the graph touches or does not cross the x-axis, it bounces. Okay, it bounces. If it has an odd multiplicity other than 1, 3, 5, 7, the graph crosses the x-axis at the 0 in what we call a bend, or I like to say squiggle for that. Not a huge deal, but here's what I'm going to tell you. The higher the multiplicity, the flatter the graph is at 0. Okay, it kind of compresses down towards it. All right. No homework this weekend. Once you get that, we're done. So, need a little bit of a break. That's all that you got to do to get high approval rating.
Is this the Brimo Sense Spirit Club?
Yes. Yes, this is the Bribe Unit Spirit Club. So for no homework, I expect everybody
Get a no homework class.
at Spirit Club. So we're negotiating some perks for Spirit Club, entry into events and all that,
Yeah. But if you don't do the pep rally. Is that so? What?
No.
I did it last year.
That's a good added bonus, except for I have
Well,
15
something
other
like
kids.
I
I did.
like all, that you that was in the last hallway last year?
Yeah, no, we have test